So today we are going to discuss about green chemistry sustainable solution for environmental production. I am Dr.D KODIMUNTHIRI, Associate Professor. So School of Basic Engineering and Sciences, BSN College of Engineering and Technology, TIRUNELVELI. Next we go to the topic. The green chemistry started after the Pollution Prevention Act of 1990. So the father of green chemistry is T. Why the green chemistry is important? Because of today most of the environmental issues arises from the industrial, especially industrial pollution. It may be organic or inorganic or biological waste from the industries. So green chemistry is the most essential one for the present world. So the main aim of the green chemistry is the source reduction or the treatment of pollution through the prevention of its formation. The green chemistry is the utilization of set of principles that reduce or eliminate the use or generation of hazardous substances in the design, manufacture and applications of chemical product. The green chemistry seeks to reduce the pollution at the source. Environmental chemistry focus on the study of pollutant, chemical and their effect on nature. These 12 principles are involved in the green chemistry. One is prevent waste, second one is maximum atom economy, thus hazardous chemical synthesis, safer chemical and product, safer solvent and reaction conditions, increase energy efficiency, use renewable feedstocks, avoid chemical derivatives, use catalysts, design chemical and product to degrade after use, analyze in real time to prevent pollution, minimize the potential for accident. So what is green chemistry? So green chemistry is about reducing the waste, reducing the materials, reducing the hazardous, reduce the risk, reduce the energy, reduce the cost in the manufacturing of chemicals. It may be organic or inorganic types of synthesis. And the main principle is designing production of chemical without polluting the environment. That is the basic principle of the green chemistry. So now we are going to see one by one about the principles of green chemistry. First one is prevention of wastage. It is better to prevent waste than to treat or clean up the waste after it is formed. That is the prevention of waste. After the production of chemical, we concentrate on the how to avoid the waste. That is not good. Better is before synthesis of the chemical to avoid the waste generation, reduce the material consumption, energy consumption. That is a better way to increase the environmental production. Second one is atom economy. Synthetic methods should be designed to maximize the incorporation of all material used in the process into the final product. That is the atom economy. It's nothing but the involvement of all the reactant, it converted to the product. So to avoid any loss of reactant or product, there is the atom economy. So for example, so formation of compound. In this reaction, first reaction, benzene oxidation with the oxygen give you a product. So product efficiency is only 44.1% in this case. The same product from the butene oxidation, we can get the 64.5%. So better method is, second one is the best method to reduce the waste generation, energy consumption and material wastage. That is called the atom economy. So best method is atom economy of organic production. through the butene oxidation. So we must select the second method to avoid the waste generation and reduce the material wastage. Third one is less hazardous chemical synthesis. So that means you must select the less toxicity chemicals. It may be a reactant or product or catalyst. It must be a less toxicity or little or no toxicity to the human health and to the environment. Not only human being and also the environment. The environment means all the living and non-living things. So fourth one is designing of safer chemicals. So chemical products should be designed to preserve the efficacy of concern while reducing the toxicity. That is more important in designing safer chemical. Fifth one is safer solvent and auxiliaries. So selection of solvent also most important in the reaction or synthesis of any chemicals. So better to avoid toxic solvent or toxic auxiliary to avoid the industrial pollution or environmental pollution. The use of auxiliary substance like solvent, separating agent should be made unnecessary whenever possible and when used innocuous. These are some preferable solvent and undesirable solvent given in the list. Preferable solvents are water, acetone, ethanol, 2-propanol, 1-propanol, ethyl acetate, isopropyl acetate, methanol, methyl ethyl ketone, 1-butanol, ester-butanol. These are the preferred solvents because of their less toxicity, easily decomposable, and does not affect the environment or other related pollution, does not give any kind of pollution. Second one is usable solvent: cyclohexane, heptane, toluene, ethyl cyclohexane, ethyl tetrabutyl ether, isooctane, acetonitrile, 2-methyl tetrahydrofuran, xylene, dimethyl sulfoxide, acetic acid, ethylene glycol. These are also possible. We can use this. The undesirable toxic solvents are pentane, hexane, diisopropyl ether, diethyl ether, dichloromethane, dichloroethane, chloroform, dimethyl formamide, N-methyl pyrrolidine, pyridine, dimethyl acetate, dioxane, dimethoxyethane, benzene, carbon tetrachlorides. These are highly toxic to the environment and human being. Some examples toxic solvent and their effect given in the table. So pentane, it's a very low plus point. There are alternative solvents available instead of pentane. So hexane, so more toxic than the alternative heptane. So classified as a HAP in USA Clean Air Act by the Environmental Protection Agency. HAP means hazardous air pollutant. So hexane is a high hazardous air pollutant. Next one is a diisopropyl ether. It's a very powerful peroxide former. So good alternatives ethers are available. So diethyl ether is a very also plus point. Dichloromethane. So high volume use of this regulated by the European countries solvent district. So classified as a HAP in US. That means high hazardous air pollutant. So dichloroethane is a carcinogenic solvent. Dichloroethane and chloroform both are so carcinogenic. So carcinogenic means it is a substance they are possible to produce a cancer. It affects the DNA or damage the DNA. So interfere with the growth of the normal cells. So try to avoid this kind of solvent, dichloroethane or chloroform. So dimethyl formamide is a toxic, strongly regulated by the European Solvent Directive. So classified as a hazardous air pollutant in the US. Same like this, like above. N-methyl pyrrolidine, pyridine. These are the toxic, carcinogenic, mutagenic, reproductive toxic category 3. So category 3 means it is possible for cancer. So over consuming of the pyridine, because of pyridine is easily volatile solvent. Over inhalation of the solvent related create a respiratory related diseases. There is a possibility for cancer. So try to avoid this kind of solvent. Dimethyl acetate and dioxane, dimethoxyethane. These are the CMR. CMR means carcinogenic, mutagenic, reprototoxic category. So category 3 means is possible for cancer producing solvent. So benzene is a highly toxic. So category 1 means more possible for cancer. So benzene is a highly volatile solvent. So try to avoid use this kind of solvent during the preparation of chemicals or synthesis. So toxic to the human and environment. Carbon tetrachloride. This also is highly toxic. So highly carcinogenic. Ozone depleter, it affects the ozone layer. We all know about that. Carbon tetrachloride is banned under the Montreal Protocol. It's not available for large scale use. Strongly regulated in the European and the US. It affects the ozone layer. So next principle is design for energy efficiency. So before we start the synthesis, we must plan which method is suitable to reduce the energy consumption. Synthetic method should be conducted at the ambient temperature and pressure. Normal room temperature and atmospheric pressure is best way to reduce the environmental related issues. Next one is use of renewable feedstock. So raw material for the preparation must be a renewable resources, easily decomposable resources. That is the best for the synthesis. So try to always select the raw material easily available and easily regeneratable or renewable sources and easily decomposable sources. That is the best way to avoid the environmental causes or environmental issues. This is an example for the raw material for renewable resources. So the Green Chemistry Challenges Award in 1999 awarded by the Biofine Industries. Preparation of levulinic acid from the easily biodegradable waste like paper mill sludge, agricultural residue waste, municipal solid waste and waste paper. It's the best method when compared to the same levulinic acid prepared from the petroleum product. So compare to that method, this is the best method because of all the resources are easily available and easily biodegradable waste material. It does not create any kind of pollution. So that they are awarded in 1999. Reduce derivatives. So during the synthesis design or plan or preparation, try to avoid the unnecessary derivation. Should be avoided whenever it is possible. Next one is catalysis. So catalyst reagent are superior to stoichiometric reagent. Wherever it is possible, try to use catalyst. It reduces the energy, time and increase the product. So selection of catalysts also more important. So catalytic reagents play a major role in the green chemistry. We are see the few examples at the end of this topic. Design for degradation. So degradation is the most important. whatever it may be we design or design for preparation, it must be easily decomposable one, because it affects the nature. The chemical products should be designed so that at the end of the function they not be persist in the environment and instead break down into degradation product. That is more important in this green chemistry. So real-time analysis for the pollution preventions. So preparation not only important, so monitoring and control the formation of hazardous substances also important. So real-time analysis of the pollution prevention is more important. Next one is incurrently safer chemistry for accident preventions. So minimize the potential for chemical accidents, including release, explosion and fires. Wherever possible, try to avoid the fire, explosion, release of toxic gases. Here one is a best example. It's a Bhopal gas tragedy in 1984. Because of the small human error, the release of methyl isocyanate accidentally released into the atmosphere. Nearly 15,000 people are died and many people are injured. Mainly they are affected with the eye. So that we are try to avoid, wherever it is possible, try to avoid the release or explosion or fires. So manufacturing plants should be designed to eliminate the possibility of accident during the operation. Wherever it is possible, try to avoid this. These 12 points are the more important principle involved in the green chemistry. Okay, now we are going to see the example to avoid the environmental issues, environmental pollution, or the method to implement the green chemistry rules. So unnecessary steps should be minimized or avoided if possible, because such steps require additional reagent and can generate a waste. In this industrial preparation method of propylene oxide, here we represent the two methods. First one is chlorochitin process. It is the old method. In this, two steps are involved to prepare the propylene oxide. So second one is the simplest method. It's a single step method. Compared to 1 and 2, second one we get a shortest method and get a more yield compared with the first one. So overall yield and atom economy will be decreased for large synthetic routes. So we must select the shortest method to prepare the chemicals. That is the best way to avoid the energy consumption, waste generation, or reactant consumption. We can reduce by using shortest method to prepare the chemicals. Use of catalyst. By the use of catalyst, need to for large quantity of reagent can be avoided that leads to the waste stream. By increasing the rate of attainment of equilibrium through the lowering the activation energy, catalyst reduce the energy requirement of the process. So by use of catalyst, reduce the time duration, increase the product, which leads to avoid the energy wastage, and we can increase the yield, better yield and atom economy. Reaction become feasible in case where no reaction is normally possible. By use of catalyst, waste is generally reduced compared to non-catalytic alternative, and better utilization of starting material. We can also use a green nano catalyst like gold nanoparticles, silver nanoparticles, so are used very efficiently in organic synthesis. Biocatalysts are also used in enzyme synthesis. It also reduces the waste generation and the time consumption. This leads to it support the green synthesis. So wherever it possible, select the catalyst. Depends upon the chemical process. It may be a nano-catalyst or biocatalyst or any kind of catalyst. The synthesis of ibuprofen is one of the best example for this green chemistry preparation. In old method, Advil Martin heparin, nearly 28 to 35 million pound of ibuprofen are produced each year. The waste generation is 37 to 46 million pounds of waste are generated in the preparation of ibuprofen from the isobutyl phenyl propanic acid. This is an old method, brown synthesis. In this method, we get only 40% of the product. So, Boost company synthesis of ibuprofen. In this, there are 6 steps are involved. So, isopropyl benzene, starting from the isopropyl benzene, aluminum chloride used as a catalyst in step 1, and then it converted to acetyl, then it converted to epoxide compound, then it converted to a keto compound, then it converted to hydroxylamine, then it converted to cyanide. Finally, ibuprofen. Nearly 6 steps are involved in this process. There are so many waste generated, and it takes more consuming, time consuming, and one step to another step there is a loss of product. Yield is very low. Only 40% of the product we obtain at the end of the process. In order to avoid this, new greener ibuprofen process. In this method, only 3 steps are involved. So overall atom economy is 77%. So yield is 77%. And waste generation, especially in this aluminum chloride is used. Aluminum oxide as a waste. In this, hydrogen chloride and acetic anhydride is used in first step as a intermediate. Second step, radionickel and hydrogen gas, natural oxidizing reducing agent. Hydrogen is used as a reducing agent, and palladium used as a catalyst. So it's a very simple process, and only 3 steps are involved. We get a more product. So compared to the previous and new method. So boot process, only 6 steps are involved. DAC process, only 3 steps are involved. In this catalyst, stoichiometric catalyst, aluminum trichloride is used here. Hydrogen chloride and palladium catalysts are used. Here aluminum hydroxide produced as a huge waste, but here very low waste generation. So atom economy 40%, here 77%. So environmental impact is high in this method. So here significantly reduced. This is the best example for green chemistry, and another best way to avoid the waste generation and time reduction is microwave assisted reactions. So microwave lie in the electromagnetic spectrum between infrared wave and radio waves. The wavelength between 0.01 and 1 meter, and operate in a frequency range from 0.3 to 30 gigahertz. However, for the use of laboratory reaction, frequency of 2.45 gigahertz is preferred, since this frequency has a right penetration depth for laboratory reactions conditions. Here microwaves used for heating purpose. Here the heat is distributed homogeneously. Teflon polystyrene container are used as a reaction vessel. solvent must be a polar, so to absorb the microwaves. That is only, these are the essential condition to carry out the reaction under microwave. So microwave assisted reaction in water. There are so many advantages by using microwave reaction in water. Efficient source of heating as the energy directly impact to the reaction medium. Rapid heating leads to saving the reaction time. Smaller volume of solvent is sufficient to carry out the microwave reactions. Diminish the waste disposal problem. So waste generation is highly reduced when we are using microwave assisted reaction in water. For example, Hoffman elimination. So microwave radiation leads to the higher yield of the unstable product in a short time. Only one minute is sufficient to complete the reaction. It's a very short duration. You can get the more yield. So loss of waste is minimized. The energy consumption is also reduced. So another one example for the microwave assisted reaction in organic solvent. So desalter reaction. So under the usual condition, the reaction requires reflex period of 90 minutes. Under the usual condition, the reaction required for the reflex is 90 minutes. Under the microwave condition, Diclime is used as a solvent. 80% of the yield obtained in 90 seconds. So huge difference between the time duration. So we can save the energy consumption. So it is the best way to reduce the waste generation and the time. We can save the time. Another one method to support the green games is ultrasound assisted reactions. Ultrasound frequencies of intersect of chemical reactions about 20 to 100 kilohertz. Esterification, for example, esterification usually carried out in presence of catalysts like sulfuric acid, para-toluene sulfonic acid, dosyl chloride, dicyclohexyl carbodiamide, etc. So these reactions take a longer time and yields are very low. But by using the ultrasound we can reduce the time duration and we can get a better yield. It's a very simple process of esterification of variety of carboxylic acid with the different alcohol using ultrasound has been reported. Advantage of ultrasound assisted reaction is this reaction was carried out at room temperature. So lesser time is required. Yield are very high compared to the normal method. These are some advantages of the ultrasonic assisted reaction. Saponification. So saponification can be carried out under mild condition using a sonification. So nothing but ultrasonic sound. By usual process of heating with the aqueous alkali, yield only 50%. The same reaction carried out the normal usual process, we can get only 15% of the product. But by using the ultrasonic sound assisted reaction, the same reaction we can get the 94% of the yield in 60 minutes. In the end, we can say that green chemistry is not a solution to all environmental problems, but the most fundamental approach to prevent the pollution. So these 12 green chemistry principles are mainly involved in the environmental protection and sustainable development. These principles are prevent the waste, atom economy, avoid harmful synthetic methods, reduce the product toxicity, use safe or no solvent, avoid high temperature and pressure, use renewable resources, omit derivatives, use catalysts, design for degradation, and process monitoring, prevent the accident, adapt from failure. So these are the 12 basic principles involved in the sustainable growth of sustainable growth and prevent the pollution. So thank you.